Hardware optimization in distributed systems with AWS and SageMaker. Definition: hardware optimization involves maximizing the performance, efficiency, and scalability of hardware resources in distributed systems to enhance processing capabilities, reduce latency, and improve overall system performance for large language models (LLM) and retrieval augmented generation RAG projects, leveraging AWS, Amazon Web Services, and SageMaker. Key components: AWS services, SageMaker, fully managed service for building, training, and deploying machine learning models at scale, integrated with AWS services for optimizing hardware resources in distributed computing. EC2, Elastic Compute Cloud instances for provisioning virtual servers with varying compute capacity and optimized hardware configurations. EBS, Elastic Block Store for persistent block storage volumes that can be optimized for performance and capacity based on application requirements. GPU instances, EC2 instances equipped with GPU accelerators for high-performance computing tasks, enhancing processing speed and efficiency. AWS Nitro System, hardware and software infrastructure that offloads and accelerates storage, compute, and networking tasks, improving overall system performance. Hardware optimization techniques, instance type selection, choosing EC2 instance types with optimized CPU, memory, and networking capabilities to match workload requirements and performance metrics. Storage optimization, configuring EBS volumes with appropriate volume types, e.g., SSD, HDD, and optimizing I/O operations to improve storage performance in distributed setups. GPU acceleration, utilizing EC2 instances with GPU accelerators, e.g., NVIDIA Tesla, for parallel processing and accelerating compute-intensive tasks like deep learning. Inference, network bandwidth management, managing network bandwidth allocation and optimizing data transfer speeds between distributed nodes to reduce latency and improve throughput. Benefits: enhanced performance, improves application performance and response times by leveraging optimized hardware configurations and high-performance computing resources. Scalability, scales computing capacity and storage resources dynamically to handle varying workload demands and support growth in distributed computing environments. Cost efficiency, optimizes resource allocation and usage to reduce operational costs associated with hardware infrastructure and improve overall cost effectiveness. Reliability and availability, enhances system reliability and availability by leveraging resilient hardware components and optimizing fault-tolerant configurations in distributed setups. Energy efficiency, reduces energy consumption and operational overhead by optimizing hardware usage and resource allocation based on workload demands and efficiency metrics. Tools and technologies, AWS EC2, Elastic Compute Cloud instances for provisioning virtual servers with optimized hardware configurations and varying compute capacities. AWS EBS, Elastic Block Store for persistent block storage volumes that can be optimized for performance, capacity, and cost effectiveness in distributed deployments. AWS GPU instances, EC2 instances with GPU accelerators for accelerating compute-intensive tasks and enhancing performance in deep learning and AI applications. AWS Nitro System, hardware and software infrastructure that accelerates and offloads storage, compute, and networking tasks to improve overall system performance. AWS CloudWatch, monitoring and management service for tracking performance metrics and optimizing resource utilization in distributed systems. Challenges. Cost optimization. Balancing performance improvements with cost considerations when selecting and optimizing hardware resources in distributed computing environments. Compatibility and integration. Ensuring compatibility and seamless integration of optimized hardware components with existing software and infrastructure in distributed setups. Performance tuning. Fine-tuning hardware configurations and optimizing resource allocation to achieve optimal system performance and efficiency metrics. Maintenance and management. Managing hardware maintenance, updates, and lifecycle management to ensure continuous operation and reliability in distributed deployments. Security and compliance. Implementing robust security measures and ensuring compliance with data protection regulations when optimizing and managing hardware resources.